Right now, before you do anything else, press your thumb firmly into the skin just above your ankle bone. Hold it there for a slow count of 5. Now let go, and look down at what's left behind. You'll see a small dent, a pale little crater in your skin that doesn't spring back right away. It fills in slowly, over several seconds. That's not your imagination, and it's not nothing. That exact test, thumb pressed into skin for 5 seconds, timing how long the dent takes to disappear, is a real diagnostic tool used in hospitals every single day. It even has a formal name and a grading scale, from 1 to 4, based on how deep the dent goes and how many seconds it takes to vanish. This isn't going to be another video telling you to drink more water or flush your lymph with a $40 brush. Your ankles swelling after 60 is not a toxin problem. It's an engineering problem. A real, physical, plumbing-level engineering problem happening in a second transport system running under your skin right now, one that moves several liters of fluid through your body every single day using no pump at all, not your heart, nothing. By the end of this, you'll understand exactly what that system is, why it starts losing ground specifically in your ankles after 60, and why that's often a completely different story than the one everybody assumes. A weak heart. Sometimes it is the heart, but far more often, something else entirely is quietly running out of capacity. Once you see it, you'll never look at a swollen ankle the same way again. Here's the pattern almost everyone over 60 recognizes, whether they've ever put a name to it or not. Your ankles look completely normal when you wake up. By 4 or 5 in the afternoon, your socks have left deep grooves in your skin. Your shoes feel a size smaller than they did that morning. And if you press on that ankle again before bed, the dent takes longer to disappear than it did at noon. Then you sleep, and by morning, it's gone. Reset, like it never happened. Same legs, same shoes, different time of day. Why would gravity suddenly start winning against you after 60 when it's been pulling on your ankles your entire life? That daily rhythm, fine in the morning, worse by evening, reset overnight, is one of the most important clues in this entire story. We'll come back to exactly why it happens. File it away. The moment most people notice swollen ankles creeping in after 60, one word jumps to mind: heart. And it's not a crazy leap. The heart genuinely can cause fluid to back up into the legs. When its pumping efficiency drops, blood returning from the legs backs up behind it, and pressure rises all the way out to your ankles. That's real, it's well understood, and it's exactly why any new or worsening swelling deserves an actual medical evaluation, not a guess from a video, including this one. But here's what almost nobody explains. The heart is only one half of a 2-pipe return system in your legs. The other half, quieter, with no chambers you've heard of and honestly no marketing at all, is very often the one running into trouble first. That's the lymphatic system. And to understand why it struggles specifically after 60, you first have to understand something most people never learn in school: how fluid gets out into your ankle tissue in the first place. Every heartbeat sends blood rushing down into your legs under real pressure. By the time that blood reaches the tiny capillaries in your ankles, vessels so narrow that red blood cells travel through in single file. The walls are thin enough, and just leaky enough, to let water and small proteins seep out into the space around your cells. That space is called the interstitial space, and the leaking isn't a malfunction. It's supposed to happen. It's how oxygen and nutrients actually reach your tissue. Here's the number that surprises most people. Across your whole body, roughly 20 liters of fluid gets pushed out of your capillaries into your tissues over the course of a single day. 20 liters. Not once. Continuously. All day, every day, your entire life. Obviously, you're not swelling by 20 liters a day, so almost all of that fluid has to come back. For a long time, physiology textbooks taught a fairly tidy explanation, one that traces back to an English physiologist named Ernest Starling, who worked out the basic pressure relationships governing this fluid exchange in the early 1900s. The classic version of his idea was that fluid gets pushed out at one end of the capillary and pulled back in at the other, almost like a self-balancing loop. Here's the part most people get wrong, and it's actually a big deal. That clean, self-balancing loop isn't quite how it works. In 2010, two physiologists, J. Rodney Levick and Charles Michel, published a major revision to Starling's model in the journal Cardiovascular Research. They showed that capillaries don't really reabsorb much fluid back in at the far end at all. Instead, a thin, hair-like lining on the inside of the capillary wall, called the glycocalyx, controls almost all of the filtering, and fluid tends to keep leaking out along nearly the entire length of the vessel rather than balancing back in downstream. Which means something important. Far more of that daily fluid load depends on a second pickup system to carry it home than doctors used to assume. Out of that 20 liters, roughly 17 does get pulled back into the bloodstream fairly quickly, through the capillaries and small veins nearby. But that leaves somewhere around 2 to 3 liters, system-wide, every single day, sitting out in your tissue with nowhere to go. Unless something else comes to collect it. That something else is your lymphatic system, and this is where the real story of your ankles begins. Scattered through your skin right now, in your ankle, are microscopic tubes called initial lymphatic capillaries. They're not sealed shut like blood vessels. Their walls are built from overlapping cells that act like tiny one-way flaps. When fluid pressure builds up in the tissue around them, the flaps pop open, fluid and stray proteins flow in, and the flaps close behind it, trapping that fluid inside the lymphatic system so it can't leak back out. Here's something almost nobody realizes. While doctors had a working picture of blood circulation by the early 1600s, this second system stayed essentially invisible for decades longer. It wasn't until 1622 that an Italian anatomist named Gaspare Aselli, dissecting a well-fed dog, noticed strange, milky white vessels running through the animal's abdomen that had never been described before. He'd stumbled onto lacteals, the first pieces of the lymphatic system anyone had actually seen and written down. It took decades more for anatomists to realize this wasn't some minor curiosity. It was an entire second circulation, hiding in plain sight the whole time doctors were busy mapping the blood supply. Once fluid is inside that system, now officially called lymph, it faces a genuinely difficult problem. It has to travel all the way up your leg, against gravity, with no central pump behind it, no heart pushing it, nothing. So how does it move at all? This is the part that, once you see it, you'll never forget. The larger lymph vessels are divided into small segments called lymphangions, each bordered by a one-way valve. Picture a chain of tiny toothpaste tubes linked end to end, each with a gate at the top. When a segment fills with fluid, its wall, which actually contains its own smooth muscle, contracts and squeezes, forcing fluid through the valve into the next segment up the chain. That segment fills, squeezes, passes it up to the next one, and the next, all the way from your ankle, up your leg, until it finally rejoins your bloodstream near a vein close to your collarbone. That squeeze and pass rhythm is a real, measurable contraction, roughly like a slow, deliberate pulse, happening independently in each lymphangion, with no instructions from your heart at all. It's an entirely separate, self-contained pump, quietly running your whole life, usually without you thinking about it once. Here's your rehook. Think about what that actually means. Your ankle is about as far from your heart as fluid transport gets, and the lymphatic system has to move that fluid uphill, through dozens of these tiny toothpaste tube segments, one gate at a time, using nothing but its own muscle. That's an enormous amount of engineering happening in total silence under your skin, every minute of every day. So what changes after 60? This is the actual, hidden mechanism in the title of this video, and it's not vague. It's specific, it's measurable, and it's been studied directly. A research group led by Dr. Anatoly Gashev at Texas A&M University's College of Medicine has spent years studying exactly this question. What happens to that toothpaste tube chain of lymphangions as an animal ages? In studies published in the journal Microcirculation, Gashev and colleagues, including Taro Nagai and Eric Breidenbach, measured lymphatic vessels directly in aged rats and found the contractions weakened. The segments squeezed less often and less forcefully than in younger animals. In one striking measurement, reported in a 2013 review in the journal Lymphatic Research and Biology, lymph flow out of the main mesenteric lymph duct dropped by roughly 60% when comparing young adult rats to aged ones. Here's an honesty pass, because that number is easy to misread. That 60% figure comes from rats, tracked across the animal's full aging timeline in one specific vessel in the abdomen. It is not a claim that a 60-year-old human has lost 60% of lymphatic function in their ankles. What it does tell us, reliably, is the direction and the mechanism. Aging measurably weakens the contractile pump at the heart of the lymphatic system. Researchers have traced part of the reason down to the molecular level too. A related paper in the journal Aging found that aged lymphatic vessels show disrupted signaling from nitric oxide, a molecule that normally helps regulate how forcefully the vessel walls contract. Picture it this way. The exact same chain of toothpaste tube segments is still there in your ankle at 70 that was there at 30. The gates still work. The vessels haven't disappeared. But the squeeze, the actual muscular contraction driving fluid up and out, has, on average, gotten weaker and less frequent. The pickup crew for that daily 2 to 3 liters is still on shift. It's just working with less horsepower than it used to. There's a second part to this aging story that compounds the first. It's not only that the pump squeezes less. The vessel walls themselves also tend to become slightly more permeable with age, meaning some of the fluid they've already collected can leak back out before it's fully carried onward. Researchers studying this describe aged collecting lymphatic vessels as somewhat enlarged and leakier, alongside their reduced contraction frequency. So it isn't just a weaker pump you're dealing with after 60. It's a weaker pump attached to a slightly less watertight pipe. Here's the part that makes this even more interesting. Because the lymphangian's own contraction is only half of the pumping story in your legs. The other half comes from something entirely outside the lymphatic system, your calf muscle. Physiologists sometimes call the calf muscle your second heart, and it's not an exaggeration, it's a mechanical fact. Every time you take a step, your calf muscle contracts and physically squeezes the deep veins and lymphatic vessels running through it, like a fist closing around a garden hose, forcing fluid upward. When the muscle relaxes, pressure inside those vessels drops, one-way valves snap shut to stop backflow, and the vessel refills, ready for the next step. Standing still gives you none of that. Gravity just pools fluid in your lower leg with nothing actively working against it. And here's a piece of simple physics that explains something you may have wondered about without ever asking directly. Why is it always the ankles and not, say, the wrists? Gravity adds its own pressure to your blood vessels, based purely on the height of the column of fluid sitting above a given point. The same reason a diver feels more pressure at depth than at the surface. When you're standing, the vertical column of blood between your heart and your ankle piles real, measurable pressure on top of whatever your heart is generating, commonly measured at somewhere around 90 to 110 millimeters of mercury in the veins of a still-standing foot, compared to just a few millimeters of mercury back up near your heart. Your wrist sits close to heart level most of the day. Your ankle sits at the very bottom of that column, every time you're upright, for hours at a stretch. Same body, same blood, wildly different pressure, purely because of where it happens to be relative to the ground. That's exactly why the ankle is the classic site for this entire story. Not the wrist, not the hand, almost never the face. Now connect that to what happens after 60. Two things tend to happen together. People generally move less, with more sitting, shorter walks, more time in a chair, and skeletal muscle mass, including in the calves, naturally declines with age, a process researchers call sarcopenia. A weaker, less frequently used calf muscle means a weaker second heart, which means less outside squeeze, helping both the veins and the lymphatic vessels push fluid upward. So now you've got two systems losing power at the same time, for overlapping reasons. The lymphangians themselves are contracting less forcefully. That's the finding from Gashev's lab. And the outside assist they used to get from an active calf muscle, dozens of times an hour, is also fading. It's not one broken part. It's two systems, both losing a bit of their push, at exactly the same stage of life. There's a third piece, And this is where the lymphatic story connects back to the assumption we started with: the heart, and specifically, the veins. Just like your lymphatic vessels, the veins in your legs rely on one-way valves to keep blood moving up against gravity instead of sliding back down. And just like the lymphatic pump, those valves and the muscle around them can weaken with age, a very common condition called chronic venous insufficiency. When those valves stop sealing properly, blood doesn't move up efficiently. Some of it pools and slides backward, and pressure builds in the small veins and capillaries downstream, right in your ankle. Remember Starling's forces from a few minutes ago? Higher pressure in those capillaries pushes even more fluid out into the tissue than normal, so now you have a genuinely two-sided problem. The venous system is forcing extra fluid out into the ankle tissue at the exact same time the lymphatic pump responsible for carrying that fluid away has already lost some of its own strength. This combined condition is common enough and distinct enough that vascular medicine has a specific name for it: Phlebolymphedema. Swelling caused by venous and lymphatic insufficiency happening together, each one making the other worse. It's described in vascular surgery literature, including in the Journal of Vascular Surgery. Venous and lymphatic disorders, and one study looking at people referred to specialty leg swelling clinics, found phlebolymphedema present in over 40% of lower leg lymphedema cases they examined, more common in that referred population than lymphedema caused by cancer treatment. That's not a general population number, since it comes from people already being evaluated for leg swelling. But it tells you this overlap isn't a rare curiosity. It's one of the most common patterns behind swollen ankles later in life, and it's frequently missed because doctors and patients alike tend to think in single-cause terms. Either it's the veins, or it's the heart, or it's the lymphatics. When after 60, it's very often two of those systems overloading each other at once. Now let's go back to that daily rhythm we filed away earlier. Fine in the morning, worse by evening, reset overnight. Because you now have every piece you need to explain it yourself. While you're upright all day, gravity is constantly pulling fluid down into your ankles, and every hour spent sitting or standing adds a little more to the load, faster than a weakened lymphatic pump and a quieter calf muscle can clear it. By evening, the tissue has accumulated hours' worth of that daily surplus, hence the sock marks, the tighter shoes, the deeper, slower-filling dent when you press your thumb in. Then you lie down to sleep. For 7 or 8 hours, your legs sit roughly level with your heart instead of hanging below it. Gravity stops working against you, and the modest pumping capacity that's still there finally gets to work without fighting an uphill battle all night. By morning, much of that fluid has cleared. Reset. That daily reset is actually one of the clearest signs separating this venous lymphatic pattern from true cardiac swelling. When the heart itself is the primary problem, fluid overload tends to be more persistent. It often doesn't fully clear overnight the same way, and it typically shows up alongside signals that have nothing to do with your ankles at all: shortness of breath, lying flat, unusual fatigue, or rapid weight gain over just a few days. Ankle swelling that's mostly mechanical, driven by veins and lymphatics, is usually on both sides, gradual over months or years, worse by evening, and meaningfully better after a night's sleep or a stretch of elevation. There's one version that breaks this pattern completely, and it's worth saying plainly. Swelling that shows up suddenly, in only one leg, especially with pain, warmth, or redness, is not this slow mechanical story at all. That combination can signal a blood clot, and it needs medical attention the same day, not a wait-and-see approach. Left unmanaged over years, this kind of chronic overload doesn't always stay as simple, reversible, end-of-day puffiness. Persistent extra fluid in the tissue, especially fluid still carrying protein that an overworked lymphatic system isn't clearing efficiently, can gradually change the physical texture of the skin and the tissue beneath it. Firmer, thicker, sometimes less able to fully pit at all, a very different picture from the soft, easily dented swelling we started with. That's part of why doctors don't treat routine evening ankle swelling as something to simply wait out, even when it isn't the heart. It's not an emergency. It's also not nothing, and the earlier the underlying mechanical load gets managed, the less chance it has of reshaping the tissue itself. Not everyone experiences this equally, and the reasons fit neatly into everything we've just covered. Extra body weight adds mechanical load onto both the venous and lymphatic systems at once, the same way a heavier backpack strains a set of stairs more than an empty one. Jobs or routines built around long hours of standing or sitting without moving remove the calf muscle assist for extended stretches at a time. And a class of blood pressure medication called calcium channel blockers works by relaxing and widening small arterioles, which, as a side effect, raises pressure inside the downstream capillaries and pushes more fluid out into the tissue, entirely independent of anything we've covered about aging lymphatics. None of these replace the mechanism we've been building. They layer on top of it, which is exactly why two people the same age can end up with very different amounts of evening ankle swelling. If you've noticed this exact pattern in your own ankles, better in the morning, worse by evening, that's genuinely useful information about your own body. If this is the first time anyone's actually explained why, I'd love to know in the comments. Now let's be honest about what we actually know here, and what we don't, before we get to what you can do about it. Let's be precise about what's solid ground and what's a reasonable extension of solid ground, because that distinction matters. The existence of stalling forces, the leaking of fluid into tissue, and the anatomy of the lymphatic system, the capillaries, the lymphangions, the one-way valves. That's basic, extensively confirmed physiology, not in dispute. The revised understanding from Levick and Michel about the glycocalyx is well established in the literature, if still newer than Starling's century-old original model. Chronic venous insufficiency and phlebolymphedema are recognized clinical diagnoses, described and treated in vascular medicine every day. The age-related decline in lymphatic contractility itself sits on slightly different footing. It's been demonstrated clearly and repeatedly in animal studies. The rat research out of Gashev's lab is genuinely robust. Evidence of similar structural changes in aged human lymphatic tissue exists too, including studies of skin biopsies showing reduced lymphatic vessel density with age. But directly measuring live lymphatic pumping strength in an aging human ankle over years, the way researchers can in a rat, is technically very difficult, so the human evidence, while consistent with the animal findings, is thinner. That's stated honestly, not hidden. And here's the part that's plausible, but not something any general knowledge video can measure for you personally. Exactly how much of your own ankle swelling on a given evening comes from lymphatic slowdown versus venous insufficiency versus a medication you're already taking versus simply sitting too long that day. Sorting out your own specific mix isn't something a video can do. It's something an actual exam does. And that's not a disclaimer tacked on at the end. It's just an honest limit of what general physiology can tell you about one particular pair of ankles. With all of that in place, here's what you can actually do. And every one of these connects directly to a mechanism we just walked through, not generic advice. First, wake up your second heart on purpose, several times a day. Since the calf muscle physically squeezes both veins and lymphatic vessels every time it contracts, and sitting still removes that assist entirely, the fix here is mechanical, not mystical. A few minutes of simple ankle pumps. Flexing your foot up toward your shin and back down, 10 to 15 times, a few times throughout the day, especially after sitting for a while. Directly reactivates that squeeze and release cycle in your calf, giving both your veins and your weakened lymphangian chain some outside help they're not generating as efficiently on their own. Standing and walking for even a few minutes every hour does the same thing on a larger scale. Done right, you should feel a mild, warm release of tension through your calf, nothing sharp. Real pain during this is not part of the process and is worth mentioning to a doctor rather than pushing through. Be honest about what this does and doesn't do. It won't repair a damaged venous valve or restore lymphangion contraction strength. It simply gives the system that's already there a mechanical boost it's currently missing. Second, elevate your legs above heart level for 15 to 20 minutes, ideally once in the afternoon and once before bed. Remember Starling's forces. Gravity increases the pressure pushing fluid out of your capillaries, and elevation directly reduces that pressure gradient, the same way lying flat overnight does, just condensed into a shorter, deliberate window instead of waiting for bedtime. Prop your calves on a couple of pillows so your ankles sit higher than your heart, not just flat on a footstool. Done correctly, you'll typically notice a mild, pleasant, emptying sensation in your lower leg within the first several minutes, lightness rather than heaviness. This won't fix the underlying reason fluid accumulated in the first place. It's giving your lymphatic system a temporary head start against gravity. Genuinely useful, even if it's modest. Third, if swelling is a regular pattern rather than an occasional one, ask a doctor about properly fitted graduated compression stockings rather than buying generic ones off a shelf. Here's exactly why they work, tying back to that toothpaste tube image from earlier. Graduated compression applies steady, gentle external pressure that's slightly higher at the ankle than higher up the leg, which does part of the lymphangian squeezing job for it from the outside, helping push fluid upward along the same one-way valve pathway. This is genuinely effective, but it's also the one action here that specifically needs professional fitting, because incorrect compression can be uncomfortable or even harmful if there's underlying arterial circulation trouble that hasn't been checked. Exactly the kind of thing a doctor rules out before recommending the right level for you. Properly fitted compression should feel like firm, even support, not pinching, throbbing, or numbness. Any of those is a sign of the wrong fit, not something to push through. Fourth, and this one's more modest, so I'll say that plainly. Several minutes of slow, deep belly breathing, especially lying down, can give the lymphatic system another kind of assist. Your body's largest lymph vessel, the thoracic duct, runs right through your diaphragm on its way to empty into a vein near your collarbone, and slow diaphragmatic breathing changes the pressure around that duct with every inhale and exhale, creating a gentle pumping effect on the central lymphatic system. This is taught routinely in clinical lymphedema therapy, and the underlying mechanism is well established. I'll be honest that research measuring exactly how much this affects fluid clearance from an ankle specifically is mixed and still developing. Some studies show a clear effect, others find much less. It's a low-cost, low-risk habit worth doing, just not one to overstate. And if I can leave you with one thing to unlearn, this was never a hydration problem, and it was never a toxin problem. Drinking more water doesn't strengthen a lymphangian's contraction, and no amount of detoxing changes venous valve competence. The system asking for help here is mechanical, and it responds to mechanical solutions, movement, elevation, and appropriate support, not to anything you drink or swallow. So go back to that moment at the very start, your thumb pressed into the skin above your ankle bone, that small dent slowly filling back in. You now know exactly what you were looking at. Not proof that something in you is simply wearing out, and not, most likely, a failing heart. You were watching direct, physical evidence of an entire second circulatory system. No chambers, no central pump, no attention. Quietly moving liters of fluid through your body every day of your life, using nothing but a chain of microscopic muscular gates and the help of your own calf muscle with every step you take. That system has been working, without complaint and without recognition, since before you could walk. After 60, it's simply been on shift a long time, carrying a load that, for specific and now well-understood reasons, has gotten a little heavier while its own pumping power has gotten a little weaker. That's not decline in some vague, unstoppable sense. That's two identifiable mechanical systems doing slightly more work with slightly less force. And mechanical problems, unlike mysteries, tend to respond to mechanical answers. It took anatomists centuries after that curious dissection of a well-fed dog to even accept this second system existed at all, let alone map how it worked. You just had the whole thing explained in a few minutes, wherever you happen to be sitting right now. That's worth a moment of its own. Maybe that's the real reframe here. We spend so much energy worrying about the parts of our body we can hear, the heartbeat, the breath, and almost none noticing the ones that have been working in complete silence the entire time. Your ankles weren't complaining today. They were reporting.